right, so you have a test tomorrow, so I guess we should get ready. So we're going to practice factoring some special cases together. It's going to be amazing. Okay, so let's start with number 2. Okay, on number 2, notice that 25 is a perfect square and 16 is a perfect square. So the square root of 25 is 5, the square root of n squared is n, and the square root of 16 is 4. So that means that we can jump to our shortcut. If you have a trinomial and you have perfect squares at the ends, then the pattern is, and if this guy is positive, the pattern is you square root the first and the third term, and you take whatever sign is this sign on the second term, and that's the sign of your answer. So the square root of 25n squared is 5n. Take this sign, and the square root of 16 is 4, and you're going to have 2 of those. So this is your answer. If you weren't sure, you can always big X. There's not a problem. You're just going to get some big numbers, and it might take you a second. But that's okay. The same thing happens on number 1. The square root of 1 is 1, and the square root of v squared is v, and the square root of 25 is 5. So in order to factor this guy, it follows the same pattern. This third term is positive, so that's fantastic. I'm going to take the sign of the second term for my factored answer. It's the square root of the first guy, taking the second term sign, and then the square root of the third guy, and that's all squared. So this is your answer. Again, you can always big X. Let's see, number 4. This is a difference of squares. So we're going to look at our first term. Our first term is n squared, so the square root of n squared is n. And our second term is 4, so the square root of 4 is 2. When you have a difference of squares, then you need 2 parentheses, one with a positive and one with a negative, and you're just going to take the square root of it each. So it's going to be n minus 2 times n plus 2. And then let me just show you one more time so you can see why that works. So we're going to go forwards. So if you were to fancy factor this, we would do n times n, which is n squared, n times 2, which is 2n, negative 2 times n, which is minus 2n, and negative 2 times positive 2 is negative 4. Well, these middle terms make 0 because if you have 2 and you take 2 away, you get 0. So then your answer is going to be n squared minus 4, which is a difference of perfect squares, which is what we originally started with. Okay, so that's why you need 2 of them. You need 2 of them to make so that when you multiply your negative 2 and your 2, you get a negative 4, and so that the 2 middle terms will cancel out. Okay, so that should be the pattern. The same thing on this guy, on number 5. The square root of 4 is 2. The square root of k squared is k, and the square root of 1 is 1. So your answer for this guy, factored out, will be 2k minus 1 and 2k plus 1. Okay, now let's go over here. These guys are pretty much the same thing, but they have a GCF. So you just have to start by taking out your GCF. So n squared minus 25, and then what you should be left with is some perfect squares. So I know that the square root of n squared is n, and the square root of 25 is 5. Okay, so keep your GCF, and then again it's just like the front side, so you do the square root minus the other square root, and then the same thing, the first term square root plus the second term square root. There's your answer. Okay, number 9. On this guy, a little bit trickier, but not too bad. We are going to see if he has a GCF. You can pick a small number and kind of go from there, or we can make factor trees. I'm going to just above here, while I have some room, I'm going to make some factor trees. So 50 can be broken up into 2 and 25, and then 25 is 5 and 5. So there's my factor tree. So 2 times 5 will give me 50. Let's do 80. 80 divided by 2 is 40, and 40 divided by 2 is 20, And 20 divided by 2 is 10, and 10 divided by 2 is 5. So there's that factor tree. 32. 32 is what? I guess we could just keep going with the 2s. 2 and 16, and 2 and 8, and 2 and 4, and 2 and 2. Okay, so with factor trees, we want the common number, the GCF, greatest common factor. So I've got a 2 in my 50, and a 2 in my 80, and a 2 in my 32. But then I have 5 to nothing left in common. So my GCF for these three numbers is a 2. So I'm going to take a 2 out, and that gives me 25r squared minus 40r plus 16. And what do you know? I know that 25 and 16, those guys, they're square roots. Okay, so the square root of 25 is 5. The square root of r squared is r. And the square root of 16 is 4. So if my third term is positive, then I can use my trick. And my trick, my little shortcut, it says that you take the square root of the first term. So my one will be 5r. You take the square root of the third term, so since it's a trinomial, and you take the middle term sign squared, and that'll be your answer. If you don't believe me, that's fine, you know. You can always big X. Or if you forget, you can always big X. All right. Let's look at number 10. No, number 11. Okay, on number 11, I'm going to take my 4 out, my GCF, and then I have x to the 4th minus 5x squared plus 4. Okay, and then I am going to factor this. Wait, hold on, sorry. Okay. So for this one, because I don't have a squared and then just a number here, you actually have to big X this even though they are perfect squares. So we're going to multiply to 4 and add to get negative 5. So that would be negative 4 and negative 1. So I'm going to place my middle term. So we have 4x to the 4th minus 4x squared minus x squared plus 4. Okay, I'm going to factor by grouping. X squared minus 4. And then of my second two terms, I'm going to take out a negative 1 so that I can have the same inside. So that would be x squared minus 4. Okay, then of my inside two terms, my greatest common factor is x squared minus 4. And then my leftover is x squared minus 1. Well, my 4 is just a 4, but my x and my negative, or my 4, my x squared and my 4 are squareds. So they can be factored out even further. So this should be x minus 2 times x plus 2, because the square root of 4 is 2 and the square root of x squared is x, and this is a difference of squares. The same thing here, so this should be x minus 1 times x plus 1. Okay, so just make sure you're very careful. If you have a fourth power and a second power, you can't skip steps. You need to make sure you factor things out using factoring by grouping and replacing. All right, let me know if you have any. Oh, wait, we have to do one more thing. The other thing I want to talk to you about is this, finding the mistake. So I did this problem, but then I made a mistake, so you have to make sure that you can tell me the mistake. I have some work laid out for you, and you're just trying to figure out what went wrong. So on this guy, it looks like I started off pretty good. I took a 4 out of my 32 and my negative 36, and I have 8 squared and 9. And then right here, because this guy is not positive, I can't just do the square root of each and break it up. So this step is not going to work, because this would have to be positive. So must be positive to use shortcut. Okay, and then also if you notice, I made another mistake here. I tried to split up this squared. I was like, oh man, If it's a squared, I can split it up because it's a difference. So I split that guy into this, but that's not going to work because the square root of 3 is not equal to 3. Silly. Okay, so those are the errors that I made. So now we're going to do this correctly, and this is what I want you to do on your test as well. So you're going to rewrite 4x to the 4th plus 32x squared minus 36. So again, we want to start just like I started. I want to take out the GCF, which is 4. So x to the 4th plus 8x squared minus 9. And then at this point, you should big X it. So we're multiplying to get to negative 9, and we are adding to get to 8. So two numbers that multiply to get to negative 9 and add to get to positive 8. So we have multiply by 9, we've got 3 and 3. That doesn't give us 8. We have 9 and 1. Oh, there we go. Okay, so if I want to multiply to get to negative 9, but I want a positive 8, my 1 should be negative and my 9 should be positive. I'm going to replace my middle term with these guys. So we have 4x to the 4th minus 1x squared plus 9x squared minus 9. And I didn't need to do this. I could just split it into the 2, but that's okay. 4, take out my GCF, x squared minus 1, take out my 9, then I'll have x squared minus 1, then I take out my next GCF, so that is my x squared minus 1, and then I have x squared minus 9. Oh, I see a difference of perfect squares, right, on both of them. Yeah, that is fantastic. So we're going to take the square root. So we have x plus 1, x minus 1, x plus 3, x minus 3. All right, so this should be our answer. Okay, let me know if you have any questions. Good luck on your test tomorrow. Bye, guys.